right, we do it again. So first we're going to find the axis of symmetry just using x equals negative b over 2a. Remember, this is in standard form, so it's ax squared plus bx plus c. So I can see my a is 1. I'm just too lazy to write that coefficient. B is 4, c is 5. And so negative 4 over 2 times 1 is negative b over 2a. So negative 4 over 2, so we got negative 2. So x equals negative 2 is our axis of symmetry. I can start to graph it as I go if I'd like. X equals negative 2, axis of symmetry, there we go. We know that our vertex is on our axis of symmetry, right? It's right in the middle. So if we have the x-coordinate, we have this formula, right, that tells us what the y is. So if x is negative 2, the y will equal negative 2 squared plus 4 times negative 2 plus 5. So that'll be 4 minus 8 plus 5 is negative 4 plus 5 is 1. So when the x is negative 2, the y is 1. So when the x is negative 2, the y is 1. We got a vertex right there. If they want a y-intercept, any graph you'll ever do, the y-intercept happens when the x is 0. So I'm just going to plug in 0 to my equation. And I get 0 plus 0 plus 5. So the y is 5. So when x is 0, the y is 5. 0, 1, 2, 3, 4, 5. And I can mirror that on the other side while I'm going. And I've already got a pretty good sketch. If you've already got this sketch going and they ask you for the x-intercept, you can see that it's never going to cross this. My parabola is opening up, right? So right now, I can see that there are none. As soon as you've got that vertex and you know which direction it's opening, because the a was positive, it was a positive x squared in the beginning, I know my parabola is opening up. I know it's never going to cross that x-axis. So if you've got this sketch going, you don't have to do any work. You can just say no x-intercepts. But if you're like, well, wait a second, I haven't been graphing it. What if I hadn't done all that work before? How would I know? Well, you can always get an x-intercept by letting the y be 0. So what happens when you let the y equal 0? So right now our equation is y equals x squared plus 4x plus 5. If I let the y equal 0, I need to solve this. And when you're solving, you're trying to see if it factors, because that's always fastest, if it works. And if it doesn't, or even if it does, quadratic formula is always there for you. So I'd be trying to factor this, and I'm trying to think of things that multiply to 5 and add to 4. And I come close with a 5 and a 1, but the signs aren't working out. One of these would have to be a negative, and I need to multiply to make a positive 5. So it's not factoring. So sad. But that doesn't mean that the intercepts simply aren't, maybe they're irrational. So there's still a chance that this has x-intercepts. Maybe they're just ugly, irrational intercepts. In which case I'm going to go to my quadratic formula. And I'm going to do, so it's negative b plus or minus square root of b squared minus 4ac all over 2a. So plugging and chugging that in, it's negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. And just examining this part underneath the square root, the discriminant, that's 16 minus 20. That's negative 4. I'm trying to take the square root of a negative number. That is not real. So when we're graphing, that means that there are no real numbers that's going to make this thing equal 0. So we go back to our conclusion that there are no x-intercepts. Aha. All right. For our sketch, we've already got quite a lot of points sketched, so I can just sketch that and be done. If your teacher wants more points, you can always plot more by making a simple XY chart. So I'll put my function in the middle. And this works for any graph. I cannot emphasize it enough. If you look at a graph and just give up and say, I don't know how to do this, plot some points and a picture will emerge. That's what a graph is. It's pretty darn cool. And I'd like to plug in points close to my vertex. So if I put in maybe a 1, I could plot that. Let's see. So I'll put in a 1, and I'll get y equals 1 squared plus 4 times 1 plus 5. So it's 1 plus 4 plus 5, and that's 10. Whoa, something happened. Oh, I was supposed to plug in a negative 1. So I accidentally plugged in a positive 1, but that's okay. That's still a good point. When x is 1, the y is 10. So when x is 1, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And then I can get points on the other side for free. So it's 1, 2, 3 away from the axis of symmetry. So 1, 2, 3 away on the other side. And there that is. And I meant to plug in a negative 1 to get that point there. So let's do that. When I plug in a negative 1, y is negative 1 squared plus 4 times negative 1 plus 5. So it's 1 minus 4 plus 5 is negative 3 plus 5 is 2. So when x is negative 1, the y is 2. Plot that point. Plot the point on the other side for free. And then we sketch that gorgeous parabola. And there he is. Oh, so pretty.